we present one-shot implicit animatable avatars with model-based priors. Creating animatable digital avatars is important for AR or VR applications, such as dancing motion synthesis and free-view rendering with pose control. Existing neural rendering methods for creating human avatars have encountered data-hungry problems. Some of them require dense input signals, such as video or multi-view images, while the others depend on specific 3D human training data, such as multi-view images or 3D scans, to train conditional models that reconstruct 3D humans with sparse inputs. However, most of these methods fail to achieve realistic reconstruction when only a single image is available. How can we learn a human avatar from a single image without extra training data? Inspired by the fact that humans can effortlessly estimate the body geometry and imagine full-body clothing from a single image, we propose a novel method to leverage 3D geometry prior and visual semantic prior for creating realistic animatable 3D humans. We call this method Implicit, which stands for combining explicit model-based priors and implicit neural representation to elicit 3D avatars. Given a single image, Implicit can reconstruct an animatable 3D avatar with two model-based priors and a hybrid sampling strategy. Specifically, Implicit introduces the semantic prior from clip pre-trained visual models, which plays an essential role in our one-shot training. During training, a novel view and a reference view are sampled as pairs. The reference view can be the input image or a neighboring view. The unseen views and poses are supervised by a pose-view consistent semantic loss to infer full-body appearance and geometry. As an extension, taking advantage of the clip models, Implicit can also use text descriptions to generate text-conditioned unseen regions. However, only using semantic prior is not enough to recover the full-body geometry. For this issue, Implicit introduces the 3D geometric prior from simple-skinned, multi-person linear model. First, in our optimization-based method, we use multi-view video frames rendered by simple meshes to initialize the pose-conditioned human geometry. Then the geometry and body poses are maintained by a soft geometry constraint during one-shot training. In addition, to create more realistic body part details, we propose a hybrid sampling strategy conditioned with simple semantic segmentation and body rotation. Specifically, it consisted of a segmentation-based sampling that locally refines different body parts of the human, and a rotation-aware sampling strategy that better recover heavily occluded views. We conduct evaluation on ZGeom, UMOCAP dataset, and human 3.6 million datasets. Quantitatively, Implicit achieves better novel view and novel pose synthesis results compared to existing strong baseline. For instance, despite being pre-trained on multiple subjects' data, Neural Human Performer produces blurry visual parts, particularly on unseen areas. And Neural Body and any nerf suffer from overfitting on single input images, leading to incorrect body geometries. In contrast, our method can generate a highly detailed avatar. It can render realistic visual appearance and consistent body shape. Implicit also generalizes well on real images with various clothing in deep fashion. Compared to PyFu and Pamir, the non-nerf data-driven clothed human reconstruction methods, Implicit produces more vivid details for clothed body appearance, such as patterns on clothes and shoes, tattoos on the skin, hair color, and facial features. While PyFu and Pamir produce blurry results limited by the distribution gap between training data and in the wild data. Additionally, given 3D scene and novel motion sequences, we can also synthesize human-scene interaction videos with reconstructed avatars, such as people dancing in front of a house. To evaluate the effectiveness of proposed modules, we also conduct a comprehensive ablation study. First, compared to explicit simple meshes, which generate noisy appearance, we demonstrate that it's necessary to use implicit representation to model the appearance with a continuous function. Secondly, for the simple-based geometric prior, we show that it's essential to initialize the model with simple meshes geometry before one-shot training, and our use of soft geometric loss allows the model to preserve body poses without overfitting to simple body shape during one-shot training. For the semantic prior, we compare our clip-based semantic loss with various model-based embedding loss. Compared to ImageNet pre-trained visual models, clip models can better recover the 3D appearance of human heads. We also compare clip loss with feature-based perceptual losses, which fail to generate occluded appearance. For our hybrid sampling strategy, we show that body part-aware sampling can synthesize realistic details on important body parts, and rotation-aware sampling prevents artifacts of mirrored appearance. Thanks for watching. Please refer to our main paper for more details. Our code will be publicly available for research purposes.